Today we have another type of right triangle problem. This time we're dealing with an angle. So you cannot use Pythagorean theorem. You can only use Pythagorean theorem when you know or want to know something about all three sides or the rates of a side length changing. Okay, so this time we're looking for what is the rate of this angle changing. Okay, we've got an airplane that is flying at an altitude of 5 miles towards a point directly over an observer. So I don't really like the drawing that they gave us. This is a much better drawing. We got a person, we got a plane, person. The plane is traveling this way, so it's going that way. The person is staying still, and the plane is traveling to a point that is right above the person. Hopefully we see that those two drawings are very, very similar to each other. In fact, they are similar right triangles. So if this is 5, this is also going to be 5. This is really what I've drawn. Straight over and straight up. So the top and bottom are congruent, the left and the right are congruent. So this is the plane. The plane is flying at an altitude of 5 miles. The speed of the plane is 600 miles per hour. So the plane has a distance from this spot that is above the person. That is, I don't know, the point above the person. The distance between the plane and that point is decreasing. So its rate is negative 600 miles per hour. This distance above the person is 5 miles. Okay. Other information. We know at one spot the angle is 30 degrees. So at some point in time, this angle theta is 30 degrees. All right, if we use parallel lines, right, bottom and the top there are parallel to each other, this angle and this angle are congruent to each other. Parallel lines, alternate interior angles. So this guy is theta as well. Okay. So things that we know, we pretty much just know this. We know this side, so we know the angle at this point in time. We know this side, and we know that side's not going to change. And then we know that this side is decreasing. So we need some kind of a formula that relates theta, the opposite side of a right triangle, and the adjacent side of a right triangle. This hypotenuse, we don't care about. This is an opposite side. This is an adjacent side to the angle that they gave us. So what kind of a formula do we know that includes an angle, an opposite side, and an adjacent side? Well, opposite over adjacent is the same thing as the tangent of theta. Remember that good old trig formula. We do not know the length of this adjacent side. Let's label the adjacent side A. How about that? A. Let's label this one the height. Let's label that one. Well, I don't want to label it O. Do we want to label it H for height? It's kind of annoying that H is not hypotenuse, but whatever. So H is the height, A is the adjacent side, and then theta is going to be this. We don't care about the hypotenuse. Okay, at a particular point in time, theta is 30 degrees. The opposite side is 5, and the adjacent side is the one that we don't know. Okay, to get A by itself, we have to multiply both sides by A, and then divide by tangent of 30. So it's going to be A tangent of 30 degrees equals 5. Then divide by tangent of 30, A equals 5 over the tangent of 30 degrees. Now remember that most of the time in calculus, our calculators are in radians mode. This is one of the few times when our calculator is going to be in degrees mode. Or the tangent of 30 degrees is not that hard to find. Tangent is sine over cosine. Sine of 30 degrees is 1/2, and cosine of 30 degrees is the square root of 3 over 2. So A is 5 times cosine of 30 degrees over sine of 30 degrees. I've got it flipped upside down because tangent was in the denominator. So A equals 5 times cosine, I said, was root 3 over 2. Sine is 1 over 2. Okay, these little 2's cancel out. So A is 5 times the square root of 3. Hey, that's not so bad. Oh my gosh, if this is a 30, 60, 90 triangle, guys, this is 5, this is 5 root 3, and then this is 5 times 2 is 10. Wow, we could have used special right triangles to find that as well. I feel silly. All right, so at this point in time, A is 5 root 3, and theta is 30 degrees. Okay, let's write all that stuff out. A equals, H equals, and theta equals. Theta is 30 degrees, A is 5 root 3, H is 5, dA, dt, dH, dt, and d theta, dt. Okay, we are looking for the rate at which, you cannot see that. Okay, we're looking at the rate at which the angle and elevation is changing when the angle is 30 degrees. So we're looking for d theta dt. That's the thing we don't know, but it is going to be measured in degrees because theta is degrees and t is hours. Hours. Because we are told that A is decreasing at a rate of 600 miles per hour. H, the height, is also going to be miles per hour, but we know that the height is not decreasing. The plane is flying just straight. I mean, it's following the curvature of the earth, but we don't get that much into it. So the plane is flying straight across, so the height is not changing, it's still 0. Now that we have our list of all of the sides and their rates, we need some kind of a formula that can relate A, H, and theta again. And it goes back to tangent of theta equals opposite over adjacent. Now remember, since the opposite number, which is H, the height, is not changing, you can plug in that 5 before you take the derivative. You are not allowed to plug in 30 because it's changing. You're not allowed to plug in A because it's changing. Okay, here we go. Tangent of theta equals 5 over A. A is the adjacent side. When we take the derivative on the right-hand side, that looks like we're going to have to use a quotient rule, but we can get around that using a power rule. We just have to do a quick rewrite. Tangent of theta equals 5a to the negative 1 power. Hey, that's not so bad. Let's take a derivative. The derivative of tangent is secant squared of theta, but we took a derivative of something that is not t, so we have to do d theta dt. Other side equals negative 1 times 5 is negative 5, a to the negative 1 minus 1 is negative 2 times dA dt. Let's do some rewrites. Secant of theta is the same thing as 1 over cosine of theta. But since this is squared, this is the same thing as cosine of theta squared down there. Bring down our d theta dt equals negative 5 over a squared, right? A to the negative 2 is a squared in the denominator times dA dt. All right, let's plug in everything we know. We've got 1 over the cosine of 30 degrees squared times d theta dt is the thing we don't know, equals negative 5 over a squared. A is 5 root 3, and we will square that, times other thing, dA dt is negative 600. Okay, almost done. Denominator is cosine of 30 degrees squared. Cosine was root 3 over 2. So this is 1 over root 3 over 2 squared. That's kind of gross. times d theta dt equals -5 over, let's see, 25 times root 3 is just 3 times -600. Okay, so I squared the 5 and squared the root 3. Over here, this is kind of nasty. Also, we got 1 over, square both pieces. Squaring square root of 3 is just 3 over 2 squared is 4 times d theta dt equals, get a positive number multiplying those together. 600 times 5 is going to be 3,000 over 75. Okay, this is divided by 3/4. So if we multiply both sides times 3/4, we will get rid of that. D theta dt equals 3,000 over 75 times 3/4. Go. So it looks like 9,000 over whatever 75 times 4 is. $300. Ooh, that'll come out nice. D theta dt is 9,000 divided by 300. 90 divided by 3 is 30. We still need degrees per hour. Okay, so theta changes at a rate of 30 degrees per hour.